Welcome once again, everyone. Welcome once again, everyone, to the day one of our Linux journey. Today, we will cover the fundamentals of Linux from its diverse distribution to its architecture and the terminal, what you call the command line interface. Okay. So by the end of this session, you will be able to, you would have understood or you will understand why Linux exists in many forms, or what we call flavor or distros that we'll be looking at, how its internal structures works, and how to interact with Linux through the terminal or the command line interface, like I said earlier. So our first number one concept we're discussing is a Linux distribution. Okay, so Linux isn't a single operating system, as you may think. It is a family of operating systems, which are known as distributions or distros. So if I use distribution or distros in the course of this lesson, no, I'm referring to the same thing. So each distro is tailored to different needs, which could range from users' friendliness to enterprise stability. So that said, if you want an operating system that your preference is stability, you will go by that criteria. So what are some of the popular distros or distributions of Linux? The most common, one of the most common one is the Ubuntu, which is known for its ease of use and stability for both beginner and servers. Okay. Now we have also the CentOS and the Red Hat Enterprise Linux, which are favored for their enterprise grade stability and production environment preference. So CentOS, as a matter of fact, is a community alternative of Red Hat Enterprise Linux, which is a commercial distribution, which actually requires a paid subscription for full support and access to updates. Okay, so we have Debian as well. Debian is renowned for its, rock solid stability, and many other distributions actually get built on Debian, meaning Debian is a base for many distribution or distros. The next one we'll look at is the Fedora or Arch Linux, which offers actually cutting-edge features and customizability. That is one of its strengths. So what actually differentiates the different distros? Each distribution has its own package manager or management system. It has its target audience and default softwares that come pre-installed with it. For example, Ubuntu uses apt and is great for, newcomers, while CentOS focuses on long-term support and reliability. Okay, so for example, imagine you are setting up a server for, let's say, a small business. But the thing is, what flavor will you choose? Pause the video for a moment. What flavor will you choose based off of what we've just discussed? Okay, so if your answer was something like you might choose Ubuntu for its ease of use, or opt for CentOS if you need, let's say, enterprise level stability, then you are correct, because that's what we just discussed. So one thing I would like you to do is just do a little bit of search on two distributions of Linux online and list their primary use or their primary use cases. And I would advise you to use an online tool like there's a distro chooser. Just go on your browser and type distro chooser. You will see how you can be able to make a decision on which distribution of Linux to use based on your particular needs. Okay. So the next question I have for you is, what are the main differences between Ubuntu and CentOS? Again, I want you to go on your browser, search, do a little bit of research. That's the best way that you get to learn, by participating, getting involved. All right. So do that and put a response in the comments of this video. So which Linux distribution is commonly used as a base? That's the third question, as a base for creating other distributions. If you want to create other distribution, which Linux distribution, existing distribution, will you use as a base? Now that takes us to our next concept, which is the Linux architecture. Understanding Linux architecture helps you know what happens behind the scene when you are running commands. Remember, the Linux, most of what you'll be doing within your Linux operating system is typing commands, right, in the command line interface. So Linux is actually structured in layers. So each layer plays a very vital role. The key layers involve the hardware layer, which is like the physical components like the CPU and the memory. We have the kernel, which is the core that manages hardware, the hardware interactions, processes, and the memory as well. So the kernel manages all of these components. So we also have the shell. The shell is the interface that kind of lets you communicate with the kernel, the shell. So we have example of shells like the bash shell. If you have heard of bash shell scripting, the Z shell, the fish shell, and so on. Now, we also have the user interface as another component, which contain the applications and the utilities that you use on everyday basis, such as the ls, the vim. All of these are utilities, right? So, for example, give you a scenario. Consider a web server. Considering a web server, right? While the web application runs in the user space, the kernel is busy managing your network connections to deliver web pages to the user. Okay, that's a particular an analogy or example we can use to describe that relationship. So for your practical steps, what I want you to do is open your terminal and run these commands that you see on the screen. uname-r to display the current kernel version. You want to see the current kernel version, go by uname-r, and you can see the current kernel version of my own machine. All right, so the next command I'd like you to do as your hands-on practice will be to identify your shell. What shell is running? What shell is running on your system, on your current system? I know many of you probably will be running on a different operating system like Windows, MacBook, and you probably don't have access to a Linux interface yet. We're going to see that in one of our upcoming videos. But I want you to master these commands, okay? To do that, you type echo $shell in all caps to be able to see the shell that you're using in your system. You can see my shell here. So, okay, I have some questions for you, and I want you to put a response in the comment section. What is the role of the kernel in Linux? What is the role of kernel in Linux architecture? Put a response in the comments below. And then again, I would like you to name 3 types of Linux shells. What are the 3 types of Linux shells you can remember? To give you a little bit more about the Linux kernel, in the Linux architecture, the kernel acts as the central core, which goes along with to manage all the system resources like the memory, the CPU, and devices, right? Effectively bridging the gap between applications and the underlying hardware. This it goes as well to allow multiple programs to access the shared hardware resources seamlessly. Essentially, it is the primary component responsible for smooth operations of the entire Linux operating system, the kernel. So, but what are some of the key functions of the kernel? If you just to give you a more deeper view, memory management is one of the core functions of the Linux kernel. It keeps track of how memory is allocated and used by different processes. It also, one of the key functions as well is process management. If you just type the ps command on your terminal, you will see different processes that are running. So the kernel also determines which process can use the CPU, when it can use the CPU, and as well as managing their execution. The kernel also is in charge of device driver or managing device driver. It acts as an intermediary between the hardware device and the operating system through device drivers. You know, when you plug in a new mouse, for example, into your computer, your Windows computer, what happens is that the mouse installs a driver. A driver is installed that helps the mouse to communicate with the operating system for your mouse or your keyboard to function the way it's supposed to function. So the kernel has a role to play in that as well. The next one we'll talk about is the file management. So the kernel provides a consistent interface for accessing files across different file systems. So the next aspect is the system call handling. The kernel enables applications to require system services through system calls. And then we also have security enforcement. The kernel implements security policies to protect the system from unauthorized access. And that brings us to the end of that concept. The next concept which is the last we're looking at in this video, is the terminal basics. Terminal basics. The terminal is your gateway to Linux. It's the door through which you can enter into a Linux system, right? Okay, it could appear, let's say, intimidating and overwhelming due to its perceived difficulty or complexity as at first, if you're using it for the first time. But mastering basic commands will eventually empower you to be able to navigate and control your system efficiently. Command syntax. When it comes to command syntax, there is a format through which you have to type commands. So the typical structure is you have the command, the option, and the argument. Okay. So let's look at some common commands. Some common commands will include the ls, which is the ls command lists files in a directory. It lists files in a directory. We have the pwd. The pwd, the cd command is known as the changes the current directory. It's used to change your current directory. Okay. So let's try this. Let's go to try navigating to the /etc directory by, okay, try navigating to the /etc directory, list its content, and then return to your home directory. So if you're doing these exercises alongside with me, I'd like you to go to your /etc directory, list the content, and then return back to your home directory. So that exercise will actually entails 3 different commands. All right, 3 different commands. Let's see if you can do it. Pause the video and try it out. Okay, so to do that, open your terminal, you type the ls remember, we are using the option ls. The option is the directory we want to list. Remember, the ls stands for list content, right, in a directory. If you just put ls, it will list the content of your present working directory. But if you do ls/ you put an option, the option in this case is the directory we want to list. So we do /etc. So that's what we'll get the content of the directory. So now we can now cd back to home. We have list the content of the directory and we cd to home. Cd to home, you do cd tilde. Cd tilde, it takes you to home wherever you are, wherever you have changed directory to, and you do cd tilde, it's taking you back to your home, to your user home. Okay, and again, your home directory is always /home/ the username /username. So it gives you the home of your user. pwd, of course, tells you where we are currently in our directory system or structure. So I would like you to experiment with different options like ls-l and ls-a to see details, detailed and hidden files. So ls-l gives you detailed files, gives you more detail, and ls-a makes you to be able to see hidden files. You can see these files that are with dot, and then the file name. They are hidden files that you will not normally see unless you put the option to see detailed files. Okay, like on your Windows system, if there are hidden files on your desktop, you have to use options to open to opt to see hidden files. Otherwise, you will only see files that are allowed to be shown on your desktop. So for your additional practice, I would also like you to practice with the following command. Use the uname-a, which display all system information. Uname-a, it display all system information. Also want you to try around, practice with this lsb_release, which gives you, that shows you your distribution detail, right? We're talking about distro, right? Your distro detail. lsb_release-a gives you your distro detail. Okay. And then the next command is who am I? Who am I display the current logged in user. So you might have many users, or you might be logging in with many different users on your system to perform different tasks that only those users can be able to perform. So for you to be able to check and know who you are logged in as, you can use the command who am I. So you can also research uname-n and uname-m. And let's see what it displays. uname-n and uname-m. You can see. All right, let's go to a question. Let's see if you understood or you've done your homework enough. What does the command or the uname-arrow command show? When you type the uname-arrow command, what will it show you on your screen? Pause the video, put your answer in the comment section. So how do you check which Linux distribution you are currently running or you're using? How do you do that? Type the command as well in the comment section. Next question is, what does the ls command stand for? What does the ls command stand for and what does it do? What does it stand for and what does it do? What is the purpose of the pwd command? what does the pwd command stand for and what is its purpose. Okay. Now we're going to set up, we're going to do, this is for our project activity. For each video that we'll be releasing, we'll be having project activity. There's not much to be done for this section, project activity. This is our initial project activities activity. So for this activity, you are required to set up and explore a Linux environment. Set up and explore a Linux environment. So there are many options for you to run a Linux environment, maybe using a dual boot on your computer, or creating a free AWS account. I'll be showing you how to do that in the upcoming videos, or installing a virtual machine on one of your system, or building your own home lab. Okay, so we'll be seeing all of those. So the objective is set up a basic Linux environment and explore system details. Try to explore your system details, like some of the commands we have seen. Your distro, you can set up a virtual machine, install a virtual box on your system, or use AWS services like AWS EC2 instance, right? Creating an instance. So you can use for installing Ubuntu on your system, be it for a dual boot or virtual box. You can use the user-friendly installation with Ubuntu, which of course we've discussed. To explore the environment, open the terminal and run commands that we've seen before, like the uname-a, the lsb-_arrow-a, and the who am I command. So when you've done all of that, play around with your system and document your findings. Write short summary, including your kernel version, distro name, and or any other information, your current user, any other information you find out in your set as you play around. And then the last thing I want you to do is create a cheat sheet with commands. As we build on these commands and move forward, I want you to create a cheat sheet of commands that you have used. Okay, if possible, write in bracket or comment beside them their uses. For example, the ls command, right, which is used to list the content of your directory, right, of a directory. The pwd command used for checking your current your present working directory, where you're located in your system, the cd commands, and so on. So it's meant to be for your own reference. So create a small cheat sheet, and we'll keep building on it as we go forward, or we'll dive deeper into our classes. Okay. So to wrap up the day, I would like you to answer the following questions. What are Linux distributions? What are Linux distributions? Why do they exist? Why do Linux distributions exist? Describe the role of the kernel in a Linux architecture. How do you find out your Linux kernel version using the terminal? What command shows, what command shows you your current user or your current username in Linux? What command shows you your current username in Linux? So today we have successfully laid the foundation for your Linux skills by exploring distribution, architecture, and terminal commands. Each of these concepts builds on the next, and as you keep practicing, you will become more and more comfortable and confident in navigating the Linux system. So feel free to ask any questions or visit exercise. Try out the exercises that I've given you. Try to play around with them to deepen your understanding, and then and you'll find out that you get better and better. So happy exploring and enjoy your journey into the world of Linux. Thank you, and see you on the other side as we dive deep into the next lesson.